This screencast will show you how to solve a system of linear equations by using the elimination method. My first example gives me 3x plus 4y is equal to 23, and negative 3x plus y is equal to 2. The goal by using elimination is to eliminate one of the two variables. You can do this by adding or subtracting the two equations. However, you may need to multiply first. In this case, I can add the two equations together and eliminate the x's because I have opposite numbers in front of x. I have a positive 3 and a negative 3. So I'm going to add the two equations together. I want to kind of visualize that there are three parts. There's an x part, there's a y part, and there's a numeric part. So if we work through the x part, when we add these together, we get 0 x's. We don't need to write 0, because when we add 0 to anything, we get the same number. The y part includes the signs in front, so I have 4y plus y, which will give me 5y. The numeric part is this 23 and the 2, and if we add 23 and 2, we get 25. Solving for y, we would divide both sides by 5, and y is equal to 5. Then I need to find x. It does not matter which original equation I substitute into. Again, we use the original because usually they have smaller numbers. So I have negative 3x plus y, which is now 5, is equal to 2. Subtract 5 from each side. Negative 3x equals negative 3. Divide both sides by negative 3, and x is equal to 1. Once again, we're going to write our answer in alphabetical order. So x comes first, y second, 1, 5. Next example, we have 6x plus 7y is equal to negative 15, and 3x plus y is equal to negative 6. I cannot add the x's together and eliminate them. I cannot subtract the x's together and eliminate them. They don't have either opposite numbers or the same numbers as that coefficient of x. I have the same situation with y. So in order to be able to eliminate a variable, I need to multiply. If I take the 3 in front of the x in the second equation, and I happen to multiply it by 2, I'm going to get 6, and that will allow me to eliminate the x's. So I'm going to do that. First equation is going to stay the same. So I have 6x plus 7y equals negative 15. My new second equation is 6x, because I multiplied the 3x times 2, plus 2y, because we multiplied y times 2, equals negative 12. And now I'm ready to try to eliminate one of the variables. In this case, I'm going to subtract to eliminate the x's, because 6x minus 6x would give me 0 x's. If we subtract my y's, we would have 7y minus 2y, which gives me 5y. And if we subtract negative 15 minus a negative 12, that's going to give us a negative 3. Now you'll notice that it looks like I'm going to get a fraction. That's okay, it can happen. Divide both sides by 5, and y is equal to negative 3/5. Now I'm looking to solve for x. I'm going to use my second equation. So I have 3x minus the 3/5, which is y, equals negative 6. I'm going to add 3/5 to each side. That gives me 3x is equal to, I need this to be in terms of 5. I'm going to multiply top and bottom by 5, which gives me negative 30/5. So that gives me negative 27/5. Now in this case, because I have a fraction, I am going to multiply both sides by the reciprocal of 3 instead of dividing by 3. And that will give me, let's see, a negative 9/5 for x. And we will get, in alphabetical order, negative 9/5, negative 3/5 for an answer. Next example, 2y minus 4x is equal to 18, and negative 5x plus 3y is equal to 23. The first thing I'll notice as I'm writing these is I don't have x and y in the same order. So in that first equation, I'm going to rewrite it. So the x is first and the y is second. 4x plus 2y equals 18. And we have, again, negative 5x plus 3y is equal to 23. Now I'm looking at that, and I need to decide, can we add or subtract as it is to get rid of x or y? I can't, because I don't have the same or opposite number in front of either my x's or my y's. Once again, I've got to make a decision of what I'd like to eliminate, and in this case I'm going to choose y. I can't just multiply once. I have to multiply twice, and y's got smaller numbers, so we're going to use that. In the first equation, I'm going to multiply by 3, because if I take 2 times 3, I'll get 6. And in the second equation, I'm going to multiply by 2. Again, 2 times 3 will give me 6. So my new equations are negative 12x plus 6y equals 54, and negative 10x plus 6y is equal to 46. To eliminate, I am going to subtract the two equations, starting with the x's. And when I subtract the x's, I'm going to get negative 2x. I get 0 y's and positive 8. Divide each side by negative 2, and that gives me x is negative 4. I can now go back and find y, and I'm going to use one of my original equations. I'll use the second one. Negative 5 times negative 4 plus 3y equals 23. So we have 20 plus 3y is equal to 23. Subtract 20 from each side. 3y is equal to 3. And divide each side by 3. Y is equal to 1. Again, in alphabetical order, negative 4, 1 will be my solution to this system. Okay, new example. 3x minus y is equal to negative 2. 9x minus 3y is equal to 3. Again, I do not happen to have same coefficient in front of x or y. Don't have different the opposites, so got to multiply. I'm going to get rid of x, so I'm going to multiply the top equation by 3. And that gives me 9x minus 3y equals negative 6. I already had 9x minus 3y equals 3. I'm going to subtract to eliminate my x. That gives me 0 x's, and it gives me 0 y's. I cannot leave that left side blank, so we're going to put an equal sign, a 0 there. And on the other side, negative 6 minus 3 gives me negative 9. This is a false statement. I can't have 0 equal to negative 9, and since that is the case, there is no solution to the system. There is not a solution that will work in the first equation that will also work in the second equation. Last but not least on our list of examples today, 3x plus 2y is equal to 5, and negative 6x minus 4y is equal to negative 10. Again, I can't eliminate by addition or subtraction right off the bat. I have multiplication to do. I'm going to multiply my first equation by 2 so that I can eliminate my x's. 6x plus 4y is equal to 10. And I have negative 6x minus 4y equal to negative 10. To eliminate the x's, I'm going to add them together. So I get 0 x's. I get 0 y's. So I need, again, 0 there. And on the other side, I get 0. This is a true statement, and because it's a true statement, anything will work in the first equation and in the second equation at the same time. So that means I have infinitely many solutions to this problem. And that concludes the explanation on solving systems by elimination.